In this video, we are going to look at some more examples of integrals that include composite functions and products, and we're going to see if we can use substitution. However, on these, our substitution is going to use a few more algebra techniques to try to solve it. All right, so here, let's look at this first example. Here we have x times the square root of x plus 6. We see the square root of x plus 6. That is a composite function. The inside function is x plus 6. So we might consider saying u is equal to x plus 6. And du then is just equal to dx. So we could rewrite this as the square root of u du. But then we still have this x out in front. So how do we deal with that? Well, we can deal with that because we said u is equal to x plus 6. So if u is equal to x plus 6, then x is equal to u minus 6. And so this is now the integral of u minus 6 times u to the 1/2 du. Now, does that get us any closer to solving this problem? Well, it turns out it does, because by making this substitution, we can now take this u to the 1/2 and we can distribute it to both pieces. And so this is the integral of u to the 3/2 minus 6u to the 1/2 du. And so to integrate this, we will add 1 to the power. We can separate these. So u to the 3/2, u to the, add 1 to the power, divide by the new power. For the u to the 1/2, that will become u to the 3/2. Divide by the new power, so we have 2/3 plus c. And then we need to change back to the original variable. The original variable was x. U is equal to x plus 6. So this is 2/5 x plus 6 to the 5/2 minus 4 x plus 6 to the 3/2 plus c. So we did the u substitution. The u substitution allowed us to get to somewhere where we could solve this, but it did require a little bit more work. Next we have the integral of x squared minus 1 over the square root of 2x minus 1 dx. So here, how are we going to deal with that? Again, we see a composite function. We see that in the denominator. Let's consider saying u is equal to the inside of that composite function, 2x minus 1. So du is just 2dx. We're missing the 2 from our dx, so I'm going to tack it on there, and I'll tack on a 1/2 out in front. So we now have a 1/2 integral of u to the negative 1/2. We have the du, but we also need to deal with this stuff on top. So we need to change those from values of x's to values of u's. So if u is 2x minus 1, then x is u plus 1 over 2. So we can replace that x on top by u plus 1 over 2 squared minus 1. If we make that change, then that top part, this stuff right here, that is going to FOIL out to, let's see, we'll have a u squared plus 2u plus 1 over 4 minus 1. And so we have a 1/2 integral of u to the 3/2 over 4 plus 1/2 u to the 1/2 plus, nope, minus 3/4 u to the negative 1/2 du. So this part becomes u squared over 4 times a u to the negative 1/2 will give us a u to the 3/2 over 4. This piece is u 2u over 4, or 1/2 u, times a u to the negative 1/2 gives us u to the positive 1/2 times that 1/2. And here you'll have a 1/4 minus 1 gives us a negative 3/4 times that out in front. Then add 1 to the power for each of those and divide. So you have u to the 5/2 plus u to the 3/2 minus 3/4 u to the 1/2 plus c. And change back to the original variable. So we need to change all that stuff back to x. And so we'll end up with 1 over 20 times 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 5 to the 3/2 minus 3/4 2x minus 1 to the 1/2 plus c. Make sure that this 1/2 out here, that 1/2 was in front of that integral, that is getting distributed to every single one of those pieces. So if you felt like I might have been missing a 1/2 or missing a factor of 2 on these things, I was not. That 1/2 got distributed to each of those pieces. Perfect. Come back for our next video, and we will see how even and oddness of functions affects their integrals. We will see you there.